want to use interval notation to represent each interval described. And so I want to just begin by talking about interval notation and what that looks like. So when we have an open interval, we want to use parentheses. Parentheses means we do not include the beginning value, nor do we include the end value. Closed interval is when we use brackets, which means the beginning and the end numbers are included in that set of values. And then we can have both open and closed in an interval notation. So if I'm looking in number 1 at all real numbers greater than or equal to -3 but less than 5, my beginning value -3, my ending value is 5. And because it says numbers greater than or equal to, that does include -3, but only less than 5, so it does not include 5, so I use my parentheses. Number 2 says all real numbers greater than or equal to -100. So from -100 to infinity, and it does include -100, so greater than or equal says to include -100, and then up to infinity, since infinity cannot be included as an ending value, we use parentheses. Number 4 is asking to identify the intervals of increase and the intervals of decrease for each function. And it just reminds us there that we're always looking at the values over the domain. So one thing that I do to begin the problem is I take maybe a highlighter and I mark my x value at the point where I notice that it comes down at the minimum and then it starts to increase again. So from my decreasing to my increasing, I just point out my x value. And I do that in each of these problems before I decide what my interval of increase and decrease is. So in this first parabola, we notice this first function. We notice that we are increasing from this point to positive infinity, and we're decreasing from negative infinity down to, but not including this point. What we want to remember at this point at -3, it's neither increasing nor decreasing. So from negative infinity to 3 to positive 3, and not including either one of those, the function is decreasing, and then it's increasing at, that's -3, from -3 to positive infinity, -3 to positive infinity, my function is increasing. In this situation, I have the increasing function from negative infinity to positive 1, and then from positive 1 to negative infinity, it's decreasing. So my increasing interval, negative infinity to positive 1, not including 1. At 1, it's neither increasing or decreasing. And then at positive 1 to positive negative, I'm so sorry, that should be positive infinity. To positive infinity, we have a decreasing portion of the function. So here we have to identify several key features of this model rocket as it's being launched from the ground. It has an initial velocity of 60 feet. And I notice we have to look for the absolute maximum, the zeros, the domain, and the range. And what we have to remember when we look at the domain and the range, we can look at the domain in terms of what the graph looks like, but in terms of the problem, in context of what the situation is, that will be different. And the same with the range, the graph will be different than we're missing context here, so we'll put that back in. What the context of the problem is, what the range would be. So first thing I want to do is to go ahead and put this into my graphing calculator. if I want to find my absolute maximum, let's first of all, let's see if it looks graphs correctly. So I noticed that my window is not very clear. It has just some extra room up here that I probably want to try to eliminate to maximize the area of the graph that I can see on the screen. So I might want to change my window, and I notice that it's 1, 2, 3, 4, maybe 5. My x value, have my maximum be 5 on the x-axis. And let's take a look if that definitely works a little bit better for my x-axis. For my y-axis, probably can bring that down a bit from 160. Let's take a look at what happens if it's at 100. All right, so I see quite a bit, a little bit better visual of what this problem looks like. And I want to find the absolute maximum, so I do second function, and then I come on over here to calculate. And that's selection number 4. When I click on selection number 4 for the maximum, it gives me the blinking cursor, and I want to move that cursor to the left. Hit enter. Move the cursor to the opposite side of the parabola, to the right. Hit enter. And then I'm going to hit enter one last time. And it gives me my maximum value of 1.87, comma, 56.25. Now, what that means is, in our graph, we have our time in terms of seconds. We have our height in terms of feet. So after 1.87 seconds, my maximum height is up at 56.25 feet. So let's just take a moment, let's go back and let's take a look at what this graph looks like. We see what it looks like in our graphing calculator. Now let's go ahead and draw a nice graph on our graph to represent the path of this model rocket. So to do that, I want to take a look at my table. I want to make sure that my table is set up correctly. So I'm going to start at 0, and I'm going to have my table just go up by 1s. It's probably the best way to use the table for graphing purposes. So I have, oops, pull that back up here again so I can put that. At 0, 0. I'm launching at 0 time. My rocket has gone 0 feet. In 1 second, my rocket is at 44 feet. 2 seconds, 56 feet. 3 seconds, coming back down again, 36 feet. And at 4 seconds, we're actually below here. So probably could do a little bit better here at getting some more values for x and y. And the way I can do that is change my table set so that instead of going by 1, I can go by 0.1. And then I have maybe some extra values here that I can put in. So let's take a look like at 1.5. My height is 54 feet. Now that was real helpful. At 2.5, I'm at 50 feet. That could be a little bit more helpful. 2.5 is at 50. Let's look at 3.5. 3.5 is at 14 feet. So here's 3.5. right, so I need to look at my zeros. Well, it's easy to and very clear to see that one of my zeros is at 0, 0. And I have another 0. It's over here. It's in between 3 and it's in between 3 and 4. So to help us with that, we can take a look at second calculate. We can find our zeros by selecting choice number 2. And since I'm pretty sure that I know one of my zeros is at 0, 0 because the rocket is being launched from the ground at 0 seconds. I can find my other x-intercept. My cursor is at a place where I'm ready to select enter. And then as I bring the cursor down, I want to go past the x-intercept or go past the x-axis. The way that I know that I'm past the x-axis is if you look here, it says y is equal to -2. So I'm below the x-axis at -2. So I can hit enter again and then enter a third time. And so my second x-intercept, or 0, zeros is the same as x-intercepts, is 3.75, 0. And what that means is after 3.75 seconds, the rocket is back on the ground, 0 feet on the ground. My domain. So the entire graph would continue infinitely. And so for the domain, it would be all real numbers. But in terms of the context of the problem, so let's just remind ourselves, domain is from the beginning to the end. From the beginning to the end. So here's my beginning and here's my end. So it begins at 0. It ends at 3.75 seconds. Remember my x-intercept or my 0 here. So my x values are anywhere between and including 0 and 3.75. So x is greater than or equal to 0 and x is less than or equal to 3.75. Now in terms of the range for the entire graph, all the values of this parabola for the range are all the y values less than or equal to, my maximum height was 56.25. So I remember that value from right up here. My maximum height was 56.25. So in terms of the entire graph, the entire parabola, all my y values will be less than or equal to 56.25. But in terms of the context of the problem, the rocket never falls below 0 feet. So my range of values from lowest to highest, lowest is 0, highest is 56.25, describes what all my y values are, including 0 and including 56.25. In number 10, we have to begin by writing the function for the path of the ball. And we're going to begin with our vertical motion model. And just to remind you, this represents the height at any given time. T is the time in terms of seconds. V sub 0 is my initial velocity, which is my initial speed, and h sub 0 is my initial height. So at the beginning, when the situation begins, where is the height of the golf ball? And in this situation, it says that we have an initial velocity of 100 feet per second, and I'm going to say that the ball is being hit from the ground. So that means my initial height is 0. So using those two values, I'm going to say that my function is going to be h of t is equal to -16t squared plus my initial velocity is 100. Don't forget times t because it starts from the ground, my initial height is plus 0, so I can just leave the function as it is. Part B says find the highest point that the golf ball reaches and at what time did the golf ball reach this particular height. So this problem is asking me to find the maximum. So we're going to start by changing this function. And let's take a look at the path here. So my screen does not show the entire path of the problem. So I want to change my window here. Let's see, 1, 2, 3, 4. It looks like probably should go to at least 8. And gosh, let's check out 200 and see if that gives me enough height. So that looks pretty good. And I see my 2x intercepts and I see where my maximum is. And so to answer part B, I'm looking for the maximum. So I'm going to do second calculate, come down here to choice number 4, where it says maximum, and get my left side bound, move to the left side, hit enter, move to the right side, hit enter, and then hit enter a third time. If you don't have a graphing calculator, you can go on to desmos.com, desmos.com, and there is a graphing calculator that you can use, which I think I prefer actually better than a graphing calculator. But at any rate, we notice here that we have a maximum of 3.13 seconds. So it says at what time did the golf ball reach this height? That would be at 3.13 seconds. And what was that maximum height? My y value is 156.25. Right, so what I remember is, we'll come over here and we'll graph this. Matter of fact, let's do that right now. My x values represent time. In terms of seconds. And my y value represents my height. In terms of feet. And let's take a look here at our table so we can get some points. So I'm going to go to my table set and start at 0 and go up by 1s and see if that helps me to get some points that are easy to graph. So 0, 0. 1, 84. 2, 136. 3, 156. 4 is back down to 144. 5, 100. 6, 24. So now I need to find the zeros of the function and then interpret what those mean in terms of the context of this problem. So my first 0 is right here at 0, 0. Right here, 0, 0 is my first 0. And what that means is at 0 seconds, the ball is at 0 feet, which means it's on the ground. My second zero is over here, and it's a little bit past 6, so I'm going to take a look at my graphing calculator to help me to find that zero. To do that, I go to second calculate, and I go down to where it says zeros. And once again, I'm going to get that blinking cursor. I'm going to enter that first value, and then I'm going to get that cursor to go past the x-intercept. So I'm going to remember to make sure that it gets my y values are my negatives, and I'm at negative 2.67, so I'm definitely below the x-axis. Enter the second time, and then enter a third time. So my second x-intercept, or my second zero, is at 6.25, comma 0. Which means at 6.25 seconds, ball is back on the ground. Completed its path, and it is at 0 feet back on the ground. Find the y-intercept of the function, and again interpret in terms of the problem. So my y-intercept is the same as my x-intercept, one of my x-intercepts at 0, 0. And again, it has the same meaning that we wrote up here. At 0 seconds, the ball is at 0 feet, which means that it's on the ground. Now we need a reasonable domain and range. So what that means is it needs to make sense in terms or in context of the situation. So let's start with the domain. The domain is my beginning to my end value, beginning to end on the x-axis. So on the x-axis, the parabola begins at 0 time, and it ends at 6.25 seconds. So it begins and includes 0, and it ends at 6.25, and includes 6.25. So this would be my domain. My range is my lowest to my highest. Well, the lowest that the ball is, the lowest is at 0, and the highest was up at 156.25 feet. So from 0 to 156.25. Another way to write the range is from 0 to 156.25. So y is greater than or equal to 0, less than or equal to 156.25. We can write the range or the domain either in interval notation, or as an inequality. After approximately how many seconds is the golf ball at a height of 80? So if I go back up here and I look at my graph for a height of 80, we'll just put a line here so that we can visually see at 80, my golf ball is actually in two different locations. The golf ball passes through a height of 80 at this point, which is just about 1 second, and it also comes back down again and hits 80 feet at something a little bit more than 5 seconds. So we need to find out what those two time values are, and we're going to use the graphing calculator again to find those two values, and we're going to use the table to help us with that. So I'm going to just see where I am at my table right now. On my table, I notice that I have, I'm close to 80 feet. I notice at 1 second I'm at 84 feet. At 1 second I'm at 84 feet. So I really want it to be 80 feet. So what I need to do is I need to zoom in a little bit on my x values. And the way that I do that is I change my table value. And instead of going up by ones, I can go by either 0.1, or if I want to be even more exact, I can go by 0.01. So I notice it's very close to 1. If I look over here on my graph again, it's very close to 1. So I'm going to start at 1 so I can get quite close to 80 feet here. So I'm just a little bit above. So if I scroll, I notice that there's two values there that are very close to 80 feet. One is at 0.94 seconds and the other is at 0.95 seconds. But if you look closely, and if you think about money, you can ask yourself which value is closer to $80. Would that be $79.86 or $80.56? So I'm going to go with the $79.86 is closer to 80. And so I'm going to select the time of 0.94. So one of my times, how many seconds, is 0.94 seconds. Then I have to go back though and remember that I have, let's go back up here, I have another time, a little bit past 5 seconds that is also going to hit right here at 80 feet. So go back to my table and I want to really jump down to my x value of being closer to 5 because I know that it's much closer to 5 seconds. So instead of starting at 0.92, let's go to 5 and see if I can get close to 80 again. So not real close, but if I move down, I'm going to reach it here real quick. And there again, I need to decide between 5.3 and 5.31. And I think I'm going to go with 5.31. 5.31 is a little bit closer to 80. So the second time that the golf ball reaches a height of 80 feet is 5.31 seconds. All right, let's review number 11. This is from a previous section, but it's always nice to kind of go back and talk about what we did in terms of an area function. So what I notice here is I'm using the side of the house to fence in my garden area. So I'm only going to fence 3 sides of the garden, not the 4th side. And I have a total of 40 feet to fence in all 3 sides. So I need to take a look at my leftovers. So I have 40 feet to begin with, and I notice that I have to subtract 2 W's. And all of that is considered my leftovers. So let's undo that. I want to grab this whole thing here. Let's just take this portion. Whoa. Okay, it's not going to let me do that. So let's just rewrite that. So all my leftovers, 40 minus 2W, have to go on this length right here on this 3rd side. So I have my 40 altogether, 40 for the whole, all 3 sides, minus my 2 W's, and all those leftovers would give me my length here. So if I want to write an area function, A of W, what I remember is finding the area of a rectangle, I multiply the length times the width. Okay, multiply the length times the width. And I can leave it as it is, or I can distribute. And I can rewrite it if I need to in standard form. And I can input any of these 3 functions into the calculator, and the calculator will be able to graph in any form. So to find the dimensions of the garden that will provide the largest area, it's asking me for what is the maximum area. So what I remember is when I'm looking for the maximum, the largest area, I'm going to use my calculator, and I'm going to use that menu where it gives me the maximum. But before I do that, I need to put in my function. So I'm going to go ahead, I'm just going to use a function in the first function that's listed there, x parentheses 40 minus 2x. And let's take a look at this graph. And unfortunately, I don't see the maximum in that screen, so I need to change my window here. 1, 2, 3, 4, 5, 6, 7. So I'm going to probably have to go at least to 20. So I'll just change that to begin with. and that seemed to have worked. So to find my maximum, I'm going to do second, calculate, come down to choice number 4, get a little bit to the left, hit enter. To the other side of the parabola, the opposite side, hit enter, and hit enter one last time. All right, so I see two numbers there. My first value is an x value. It says 10 with round things, and my second value is 200. So let's talk about what those two mean. My maximum is 10, 200. What that means is when my width is 10 feet, my area is 200 square feet. Okay, so my x value tells me the width, what is W, what is my width, and the y value in this ordered here tells me what the maximum area is. Now if I want to find the dimensions of the garden, here's what I know. Here's my garden. I know that my width is 10 feet. Don't know what my length is, but I know that the area is equal to 200 square feet. So I can find my missing dimension by taking 200, dividing it by 10, to get a value of 20. So my dimensions are 10 feet by 20. Now another way to find your missing dimension is to take your value for W. So right here we have W is equal to 10. Take my value for W and replace it right here. So I have 40 minus 2 times W, or 2 times 10, and 40 minus 20 gives me a value of 20. So there's a couple of ways to find that missing dimension. All right, first differences and second differences. Now, great review question. I'm going to look here, and I notice that these numbers are going up. And if I want to see what they're going up by, all I do is I just subtract 48, 27. So 48 minus 27. So those numbers are going up by 21. And sometimes if I'm going up, I go ahead and put in a positive value. I don't need to, but I can. And then from 27 to 12, I notice that I'm going up by 15. From negative 12 to negative 3, I am going up by 9. And from negative 3 to 0, I'm going up by 3. For my second differences, from 21 to 15, I'm going down by 6. From 15 down to 9, down by 6. And from 9 down to 3, going down by 6. So what this tells me is if my first differences are different and my second differences are the same, then I have a quadratic function. Here my first differences are down by 2, down by 2, down by 2, and down by 2. So right away, I know if my first differences are the same, this is going to be a linear function. But another feature is when my second differences are all 0. That also tells me that I have a linear function.